Hello everyone. Today we are going to continue with ComputerCraft, and this is episode 11 already. Today, after looking at turtles, the basics in the last 10 episodes, we are going to move away from turtle scripts this time. We are going to look at a bit more general stuff. We will start this turtle during this episode. Just to figure out if it will break at some moment, and if that happens, then we're going to investigate. But I kind of hope that that is not the case, since that would mean that we have built a solid script. I'm going to start it now and let it mine, 30 slices. We shall just see where it goes from here. Well, it starts. Luckily, it starts like we would expect it to be, and that kind of leads us into stuff that we are going to do this time, which is looking at ways to transfer data. Now, I've explored a little bit of this in my own time off camera, and I've noticed that we can improve a whole lot on what I usually did. So what I usually did is transferring the ID of the PC and what it was doing. And that was pretty much everything that I sent into the network and hoped that it would do something with that. Well, I noticed at the end that if you do that, you're quite limited to what you can send over the network. So I want to make it a bit more general, a bit more future-proof this time. And I will first show you what I used in the past. That's not that far away. It's here on the monitor. Let's see how it is called. It is of course called Startup. I believe, yeah, it's just Startup. Close this. Not a fancy way of doing it. The absolute opposite. That will work for now. So what I previously did was finding my modem. Well, I had to give that ideal, so we're going to change that. See when the monitor is. Positions is something with spawn, that's a GPS. It will come later. And then it will just wait for a modem message. That's the event if something happens with a modem. Giving the input number 4, that's actually the useful part. The modem message, and then do some stuff, check if it is a string, should be. If it isn't, then there's a nil, and then, well, we don't want the program to get on, well, kind of stuck. We want to print it, so we need to find the cursor, and we need to write it with the time format, so on screen. I did also print on which time it was, I believe also the day, yeah, OS day, and then the actual input. Input 4 was the message, and input 5 was the ID of the sending computer. So that was all in there, and if there was more than 25 lines, well, then the monitor would fill up, clear the thing, and that was pretty much all it did. If input 5 is positions, then there was something with a table, but that didn't really work. So this is pretty much what I had running for a long time. And obviously it works, but it isn't really that nice. You are just limited to one piece of information, and if you want to send your GPS coordinates, for example, you need more than that. So that's where the switch is going to be towards sending tables instead of strings. And you need to be a little bit creative with that, since sending a table is not possible over the wireless network or over the local network. That's also not possible. But instead we need to convert it to a string, And on the other side of the connection, we need to make it a table once again, so we can do some useful stuff with the actual information. As you can see here in the small script that I have is print something, print table 2, which should be this number. If everything goes all right, then we are going to convert the table to a string, that we use the serialize part of the text-to-details API. Then we have, well, we are going to try and print the type of this variable after it is serialized, which should return a string. Then we are going to unserialize it once again, so it should be a table once again. Then we check if it is a table, and then we print content of the first container of the table, if everything works. So we see that 314 is indeed value 2 in here. Then we see that this is going to convert, and it is a string. So then from a table to a string. Then we unserialize it once again, so we make it a table again. And then it does indeed print table, and the first content is test. So that's awesome that works. But like I mentioned, we have to specify the actual place of the modem, and I want to make that a bit more general. So we're going to make a function which I'm going to call find modem. Function find modem. Do we need to give it a piece of information? Yes, so I want to give it an option to find for either a normal modem, a wireless modem, or an Ender modem. I'm going to distinguish between the last two. I don't know yet. Let's focus on that. So we give this is wire. If we need something for all the sides, that's going to be a local variable. Equals, there's going to be a whole lot of typing. Or actually, let's do this in the config file, since we will be using it on several places. Was it really in config? Not really in config. Nah, it's not really in config. So one or start the table. And it doesn't really matter in which order that you do those, but so that are all the sides. Table is ended once again, and now that we have all the sides defined, is that difficult? We're just going to loop through all of them. So we need another variable, local n equals 0 for n equals from 1 to, I'm lazy, I'm not going to count the number of stuff inside. That's 1, do, and we want it to go through all the sides and then see if that's going to work. So if, no, we can just wrap it. Wrap, and then there's going to be side number n. If, and this is going to be modem equals that. If modem dot, I believe, is wireless. Let's actually look that up on the. There is actually some information for that inside of ComputerCraft itself. So open, that's correct, is open, transmit is wireless. Of course, what we, oh wait, aha, there we have something. To learn about using API connecting peripherals, when a modem is connected, peripheral.getType will return modem. So that's exactly what we want, actually. Graphics exposed by modems is open, it's for your channel, is open, it's checking if there's a channel open. Close your channel, close all channels. It would suggest that you can open multiple channels. Okay. Events fired by a modem is modem message. When a message is received on the open channel, arguments are name, channel, reply channel, message, distance. Oh yeah, that's what I sent. Okay. Let's see what we are going to do with that. So we needed the peripheral.getType here. Okay, we can this actually do later. If .getType equals to modem, then do more stuff. So if it isn't a modem, it should not come here in the first place. Is wireless. Oh, that's going to mess up some stuff. Let's move that is there. If that is true, that's great. Let's set it equal to wireless. Make this a small w. So if we give it some information, let's say true or false, that's kind of what we give with this. So if it is true and returns that it is wireless, then we have found our modem. That's kind of what I'm typing here. And if we ask for a non-wireless modem, if a wireless is false, then if this does also return a false value, it will be equal, and then we will have found our interesting. That will work. It will just return true or false. So if it is correct, then that's all right. And if it is correct, it will also return a side. Okay, will work. Return true, side. And we don't really need more than that. And if it is a modem, then we want it to return false. That side. And we don't need the side then, I think. Wait, it won't get out of here. Oh yeah, this will work. This is good. This is good. Anything, then just return false as well. Return false. So let's go over it one more time. Find all these sides that we want to scan. That's just a variable that we need. And we'll go through all the sides one by one. Get the type of peripheral that is at the side. Oh, that's an interesting thing. Do we need to wrap it first? What does this say? When a modem is connected, it will return. I think we need to give it the side. Otherwise it will know where to look, of course. It doesn't really say it in the information up there. But help peripheral. What does this give us? Yeah, type and then the name. What is suggested by name? I would say just the site that you are trying to scan. Oh well. Let's save this. Copy that over from our turtle, which is actually running that exact Brave API. Paste. And then get in here. That was just checking if there was modem. Need to a bit more, of course. If brave.find modem, and we want a wireless through, then we need to run this first, give it to a few variables, and call wireless on my side. It will return two values. And if wireless equals, it will return true in our case. Then modem equals peripheral dot rep, and then side. And this should do everything we want. Of course, there's stuff going wrong in a few seconds. Attempt to index a nil value. Okay. Oh, we don't have the Brave API loaded. API, which makes sense. Lua, please. Save and run again. Attempt to index at line 33. Close that one, actually start developing on this one. Line 33, we made a typo somewhere. Attempt to index a nil value. N. Sides, yeah, makes sense. And then, of course, then we have sides again. And that should be the last sides. Oh, then. Oh, still. 140, 34. That's a mistake I made a lot in the past. And that makes everything work again. Can we make this a bit more neat? I don't think we really can, to be honest. Since we need to do this modem peripheral wrap thingy inside of your actual function that you want to do. So you need to set up some stuff if you want to send and retrieve some data. But I think that is a start of a nice piece in the API, which we can expand a little bit on. And with that, I mean we can make it work with maybe more than just modems, like a monitor. You can also check if this is an advanced monitor or not. Not really necessary for us, but advanced monitors kind of act like a touchscreen and have color, so that's nice to have. And I think that for now, well, we made progress. We went from the turtle, speaking of turtle, it finished all the way. Don't see any spoiled items. Great. It refueled twice. Didn't use a chest, so that's good. So I would say that our turtle script is still running smooth, and that we made our first success, I would say, with the others, with the wireless wonders of the wireless network. So that's going to be it for this episode. Next time we will look more into the wireless stuff and develop a way to send as much data as we can, which is still necessary and useful data, but in a more structured way. So without further ado, thanks for watching, and I hope to see you next time. Bye bye.